Can you all hear me?
Yes, sir.
Okay.
Yes, sir.
So today we are going to talk about binary tree traversal and threaded binary tree. Okay. Let us try to understand what is binary tree traversal, and then we will be talking about the types of binary tree traversal. Okay. So traversing is a process of visiting every node in the tree exactly once. Okay. So uh, if you have a binary tree and you want to make a traverse to the binary tree, and then traversing of a binary tree means you will visit every node exactly once in the binary tree. Okay. So a complete traversal of a binary tree implies visiting the nodes of a binary tree in some linear sequence. Okay. So whenever we would like to make a complete traversal of a binary tree, that means we will be visiting the nodes of that tree in some linear sequence. Okay. So what kind of linear sequence I am talking about? Let us see. So since a binary tree is defined in recursive manner, its traversal can necessarily be defined in an identical recursive fashion. Okay, so as we know from the definition of binary tree, that binary tree is defined in a recursive manner. Okay, so therefore its traversal can also be defined in recursive fashion. Okay, that means there will be some kind of linear sequence in which we will maintain the traversal of the binary tree in terms of visiting the nodes in some linear sequence or in linear fashion. Okay, so since binary tree is defined in recursive manner, therefore its traversal operation can also be defined in an identical recursive fashion. Okay, so for example, one may first visit the root. Okay, then traverse the left subtree, and finally traverse the right subtree. So this is the kind of sequence that we want to make in the binary tree. Okay, so one may first visit the root. Okay, then visit the left subtree, and finally visit the right subtree. Okay, so this is one sequence. So another sequence may be someone may first visit the left subtree, and then visit the root, and finally visit the right subtree. Okay, now we can make a rule that whenever we will visit the nodes in the tree, so we will first visit, so whatever the sequence, we will visit the left subtree before the right subtree. Okay. So if we uh, impose this rule in the traversing of a binary tree, then we could have three different types of traversal. That means in the first traversal, if we consider visiting the root node first, then we will visit the left subtree, and finally we will visit the right subtree. Okay. And if we make the left subtree first, that means if we visit the left subtree first, then we visit the root node, and finally we will visit the right subtree. Okay, so this is the second sequence. And we could have the another sequence like visit the first we visit the first we visit the left subtree, then right subtree, and finally we will visit the root node. Okay, so so these three different linear sequence makes three different types of tree traversal. Now, if we want to make impose another rule, or if we want to obtain three other different linear sequence of visiting the nodes in the binary tree, then we could make a rule that we will first, whatever the sequence we will be obtained, So first uh, we will visit the right subtree before left subtree. Okay. So just like the previous rule where we maintain the linear sequence by visiting the left subtree before right subtree. Now we are making a rule to impose on the binary tree that first we will visit the right subtree and then before visiting the left subtree. So this rule will generate three other linear sequence. So in this way we could have six linear sequence, but we are but we want to restrict the visiting of the binary tree by imposing the rule that we will visit the left subtree before right subtree. Okay. So whatever the position of the whatever the position of the root node, we will be visiting the left subtree before right subtree. Okay. So we want to restrict on this rule and make the tree reversal in the binary tree. Okay. So traversing a binary tree in this manner will produce a particular sequence of tree. That means if we visiting the nodes uh, in this particular sequence, then we could have three different tree traversal algorithms or tree traversal types. Okay. So in the first, we could give the names of this traversal like pre-order traversal, post-order traversal, and in-order traversal. Okay. So in the pre-order traversal, what we do, let us talk about the in-order traversal. Okay. So in case of in-order traversal, what we do, first we visit the left subtree, then we visit the root node, and finally we visit the right subtree. Okay. Now let us consider this binary tree where we can see that in this binary tree we will first visit the left subtree, and then we will visit the root node, and finally we will visit the right subtree. Okay. Now if we consider this binary tree, and then we can have this function definition for in-order traversal, where first we will check whether the root node is found to be null or not. That means the pointer which points to the root node is found to be null or not. If it is not found to be null, then we will make the visit of the left subtree. Okay. So recursively this function in order is called to visit the left subtree first, and then we will visit the root node, and finally we will visit the right subtree. Now, what will be the output sequence, or what will be the linear sequence that to be determined after visiting the nodes in the binary tree in order fashion? Okay, in order fashion. So, in order fashion, the root node will be printed after visiting the left subtree. Okay, and before visiting the right subtree. So the output, if we determine the output sequence of this output in order traversal of this binary tree, and then we can first have the node which is rooted at D. Okay, that means the first subtree that to be visited is rooted at D. Okay, so if we consider, so here the first D node will be visited. Why D node will be visited? But if we consider the subtree rooted at D, then we could see that the left subtree of or left child of D node is found to be empty, and right subtree or the right child is present. Okay. So D is not having the left subtree. So therefore, if there is any left subtree of D or left child of D, then that node will be visited first, because the left subtree will be visited first in this in-order traversal. So therefore, if there is any left child of D, then that left child will be visited first and will be printed first. Okay. Since there is no left subtree, therefore D will be visited first. Say here D is the root node. Okay. and then G will be visited. So here we will follow the depth first strategy. So in the depth first strategy, we will first go for the uh, left subtree. Okay, that means we will first go to the depth of the left subtree. Then we will be visiting the root node and so on. Okay, so here first D will be visited, then G will be visited, and after here D, here the subtree which is rooted at D is the left subtree of node B. Okay, so therefore before we visit the node B, we will visit the left subtree which is rooted at D. Okay, so accordingly D and G will be visited. So here D and G is the part of the left subtree of B. So therefore D and G are visited. Then B will be visited. Okay. So therefore we are writing B after G, and then we will be visiting the node H. Okay. So after visiting root node B, we will be visiting the left child of E H. Okay, and then we will be visiting the E. So here E is the parent of H, and H is the left child of E. Okay, so therefore first we will be visiting H, then we will be visiting the root node of this subtree E. Okay, so once the subtree left subtree of A is completed, and then we will be visiting the root node A. Okay, so therefore we will be writing A after E. So first we visit the left subtree of A, which is done. Okay, so after having visiting the left subtree of A, we will be visiting A, which is done. Okay, and then we will be visiting the right subtree of A. So what are the nodes which are part of the right subtree? Here C, F, I. Okay, so what will be visiting first in the right subtree? So F will be visiting first because there is no left subtree of F. So therefore, F is the root node of this subtree. Okay, in which the left subtree is found to be empty. So therefore, F will be visited next. Then I will be visited, and finally C will be visited. Okay, and this sequence which is obtained by visiting the nodes in this binary tree is called in-order traversal sequence. Okay, in-order traversal sequence. The next traversal sequence is pre-order traversal sequence. Okay, so in pre-order traversal sequence, the function definition, here you can see the function definition. So in this function definition, first the root will be visited. Okay, that so here the printf function first print the data associated with the root node, and then we will be visiting the left subtree, and finally we will be visiting the right subtree. Okay, so this sequence will generate a pre-order traversal sequence. Okay, now let us look at this binary tree and try to understand how the pre-order traversal is determined. Okay, so this for determine the pre-order traversal sequence, we need to look at the root node of the subtree first. Okay, so since the root node will be visited first, therefore first A will be printed. Okay, so after having the A printed, then B will be printed. So B is the root node of the left subtree. Okay, so therefore next node B will be printed. Then we will go for the left subtree. Since B is the root node of the left subtree of A, so therefore now we will be looking at the left subtree of B. Okay, so B is the root node of the left subtree of A. Okay, now and here D and G are part of the left subtree of B, and since B is visited, therefore we will be having the node D that to be printed. Okay, so here D will be printed. So D is the root node of the subtree in which the left subtree of D is found to be empty. Okay, so therefore, uh, as the pre-order traversal says that first we will be visiting the root node, therefore D will be visiting first. If there is any left subtree, then left subtree would be visited. Since the left subtree is found to be empty, therefore G will be visited next after visiting the node D. Okay, and once the left subtree is completed after having the node be printed, and then finally we will be visiting the right subtree. So right subtree of root node B will be visiting next. Okay, so E and H, these two nodes are the part of the right subtree of B node. Okay, so here first E will be printed because E is the root node of the subtree in which the uh, right uh, right uh, right child is 8. Okay, and left child is 8, and right subtree is found to be empty. So therefore E will be printed first, then H will be printed. Okay, so now all the nodes in the right subtree are being visited after visiting the root node A. Okay, so the left subtree is completed. Now we will be visiting the right subtree. Okay, so after having the root node and the nodes in the left subtree getting printed, now we will be now the nodes which are part of the right subtree will be printed. Okay, so in this traversal, first C will be printed after node H. Okay, because C is the root node of the right subtree. Therefore, C will be printed first. Then F will be printed because F is the left subtree of C, and there is no right subtree of C. Therefore, uh, there will be A that to be printed after C, and we will be having I after having the A printed. Okay, so I will be printed after A. That means I will be visited after A. Okay, and I is the last node in the pre-order traversal sequence. Now we will be talking about the post-order traversal. So what is done in post-order traversal? So in the post-order traversal, first we visit the left subtree, and then we visit the right subtree, and finally we visit the root node. Okay. So first we visit the left subtree, then right subtree, and finally we visit the root node. Okay. So here in all these three traversal sequence, here you can see that the left subtree always found to be visited before right subtree. So whatever the position of the root node, or whatever the position of the root node in the traversal sequence, so all so always it is found that the left subtree is visited before right subtree in these three different types of traversal sequence. Okay. So similarly, in case of post-order traversal, we will be visiting the left subtree first, then right subtree, and finally we will be visiting the root node. So according to this post-order traversal, we can have the post-order traversal sequence, which is determined from this binary tree. Okay. So according to this post-order traversal, first we will be visiting G node. Why G node? Because if we consider since the left sub first we go to the left subtree of A, so left subtree of A is rooted at B. Okay, and then left subtree of B, which is rooted at D. Okay, and since the left subtree will be visited first, and there is no left subtree of D, so therefore we will be visiting the right subtree after left subtree. Since the left subtree is found to be empty, therefore we will be visiting the right subtree of G, or the right subtree of D. So here the right subtree of D is G. Okay, so G will be visited first. So First, we will write the G node and then we will write the D node. Okay, so next node that to be visited is D, and then we will be visiting H node. So here D and G are part of the left subtree of B. Okay, so according to this post order traversal rule, we will first visit the left subtree and then right subtree, and E and H are the part of the right subtree. So therefore, H will be printed next after D. Okay, why H? Because H is the left subtree of E, and there is no right subtree of E. Okay, so therefore, after visiting the H, we will be visiting E, and once the visiting of left subtree is completed, then we will be looking at the right subtree of A. Okay, so here C, F, I, these three nodes are part of right subtree of A. Okay, so after having the node B is printed, we will be printing I. Okay, so I is the right subtree of F. Okay, and since there is no left subtree of F, if there would have any left subtree of F, then that to be visited first before visiting I. Okay, since there is no left subtree of, therefore we will be visiting I first in the right subtree of A. Okay, and then we will be visiting F, since F is the root node of the subtree which is rooted at F. Okay, and F and I both are part of the left subtree of C. Okay, so once the I and F are printed, then C will be printed because C is the root node and there is no right subtree of C. Therefore, after printing I and F, C will be printed, and finally A will be printed because A is the root node of this binary tree. Okay. Any questions from this part?
No, sir.
Okay. Next, we will be talking about threaded binary tree. So, what is threaded binary tree? Now, if we consider a binary tree in which we represent the pointers, the pointers. Now, we represent the empty subtrees using pointers. Then we can make the empty subtrees set to null. Okay, that means the pointers which are pointing to the empty subtrees are set to be null. Okay, that means we are having a binary tree and we want to represent the empty subtrees using pointers. Okay, now these pointers will be set to null. The left pointer of a node whose left child is found to be empty subtree is normally set to null. Similarly, for the right pointer of a node whose right child is an empty subtree is also set to null. Okay. So therefore, a uh, large number of pointers are need to be set to null. So these null pointers could be used in different and more effective ways. So how these null pointers could be used in effective way? Now we can assume that the left pointer of a node n is set to null as the left child of n is found to be empty. Okay, so empty subtree, and then the left pointer can be set to point to the in-order predecessor of n. So I will be coming to that point, what is called in-order predecessor of some node n, some random node n. Okay, that means if there is the left pointer of a node n which is set to null as the left child of node n is found to be empty, then the left pointer, we can set the left pointer which points to the in-order predecessor of that node n. Okay, so similarly it is true for the right pointer. In that case, right pointer will point to the in-order successor. Okay, so left pointer can be set to the point to the in-order predecessor, and right pointer can be set to the point to the in-order successor. Okay. Now here you can see that here on the left hand side we have been given a binary. On the right hand side, the same on the same binary, we have two different types of two different types of edges. Okay, which connects two different type of edges which connect or which indicate the nodes. Okay, so straight line edges are very common, which connects any two nodes in the binary tree. Okay, and this relationship, the straight line edges represent some relationship like parent-child relationship. Okay, or whenever a node is having left child and right child, to indicate to have the left child and right child, we can have this straight line edges. Okay, now we could have the another type of another type of lines which are having the arrow, and this arrow indicates the in-order predecessor or in-order successor. That means the node which is not having either the left child or right child, or uh, the node is having no left child or right child. So in that case, we can set the left pointer to the in-order predecessor and right pointer to the in-order successor. So these arrow lines indicate either the in-order successor or in-order predecessor. Okay. Now, for example, if we consider a node E in this binary tree, so look at the node E in this binary tree. So E is having no left child or right child. So therefore, according to the definition of threaded binary tree, so we could have the left pointer and right pointer. So left pointer can be set to the point which points to the in-order predecessor. Okay, so in this case, in-order predecessor is node B. Okay, and in-order successor is node A. That means the immediate node which is found to be on the right of the node E in the in-order traversal sequence. So that to be set as the in-order successor. So in this case, node A is the in-order successor of node E, because the right pointer is set to the in-order successor, and left pointer is set to the in-order predecessor. So in this case, the in-order predecessor of no node E is found to be node B. Okay. So therefore, the node B is the in-order predecessor for node E. So similarly, if we consider the node D, okay, so node D is having the right child only, which is H. Okay, there is no left child of D. So therefore, we can have the left pointer which set to the in order predecessor. So in-order predecessor in this case, or in-order predecessor for node D, will found to be empty. Okay. So therefore, here you can see that the arrow is indicated nothing. Okay. So the left pointer we set to the in-order predecessor. So in this case, in-order is predecessor is found to be empty. So therefore, this arrow indicates nothing. Okay. Similarly, if we look at the node G, okay, so node G is having the left child I, but there is no right child. So therefore, the in order successor of node G is found to be empty, because G is the last node in the in order traversal sequence. Okay, and D is the first node of the first node in the in-order traversal sequence. Therefore, the left pointer of D is set to the empty in-order predecessor, and right pointer of G is set to the empty in-order successor. Okay. Now, how to indicate when we write a program for the threaded binary tree? or when we write the function definition for threaded binary, then how we will indicate this uh, this in order predecessor and in order successor, which are quite different from the normal edges, or edges, where the normal edges represent the parent-child relationship in the binary tree. Okay, so how can we distinguish between these two types of edges, or these two kind of edges? Okay, so we can take two different variable. One is left flag and right flag. Okay, so here you can see, here we can take the left flag and right flag. Okay, that means if the left flag, we can set two different values for left flag and right flag. One is 0, another is 1. Okay, if the left flag, both the left flag and right flag is found to be 0, that means if we assign 0 to some left flag value, that means if initially we could have a node which is having two different, which is having left child and right child, both the left child and right child. In that case, the left flag and right flag becomes 0. Okay, now if the both the childrens are found to be empty. Okay, if both the children are found to be empty, then in that case the left flag and right flag will be assigned by 1. That means the left pointer will point to the in-order predecessor, and right pointer will point to the in-order successor. Okay, so if you try to understand what is in-order predecessor and in-order successor, now let us look at this binary tree. Okay, so since it is the in-order traversal, and we need to determine the in-order predecessor and in-order successor for the empty left child and right child in the binary tree. So therefore, if we consider some random node, okay, so random node, let us consider h. Okay, so h is the node we need to find out the in-order successor, in-order predecessor. So can you say what will be the in-order successor, in-order predecessor for node H? The immediate left node of H is B. Immediate right node of H is E. Okay. So immediate right node of H is E. Immediate left node of H is B. So in-order predecessor of H node will be B, and in-order successor of H node will be E. Okay. So here we need to consider, or we need to determine the in-order traversal sequence first. So first we will determine the in-order traversal sequence from this binary tree. Okay. Then for every node, we will try to find out the in-order predecessor and in-order successor. If a node having both the childs, then there will be no in-order, for that node there will be no in-order predecessor, in-order successor, like some random node like B. Okay, so B is having the left child and right child, so therefore B should not have the in-order predecessor and in-order successor. The node which is not having any left child or right child, or both the childs, in that case there will be in-order successor or in-order predecessor. Okay, so here if we look at the node J, okay, some random node J in this binary tree, and J is having no left child and right child, so therefore, so both in-order predecessor and in-order successor will be there for node J. Okay, and in-order predecessor for this node J becomes D, and in-order successor of node J becomes node H. Okay, so you have to remember one thing, that you need to first compute the in-order traversal sequence. Then from that in-order traversal sequence, you will indicate the in-order predecessor and in-order successor. So therefore, the left and right links leading to the in-order predecessor and in-order successors are called threads. Okay. So which is to be distinguished from the conventional links of a binary tree. So conventional links means the conventional links conventional links create a relationship, a parent-child relationship between two nodes. Okay, but this kind of threads basically try to indicate the in-order predecessor and in-order successor when the corresponding node is not having either the left child or right child or both the childs in the binary tree. Okay, so the links are used as threads only when they would have pointed to empty subtrees in a non-threaded binary tree. Okay. So, what could be the data structure for this threaded binary tree? So, if we write a function definition to create a threaded binary tree, so before that we need to define the structure. So, in that structure, we could have five different members. Okay, so here we have the data part for a random node in the threaded binary tree, and we could have the left pointer and right pointer. So along with the left pointer and right pointer, we could have the left flag and right flag. Okay, so left flag and right flag will indicate whether the corresponding node is having the conventional link or uh, it is having the threads which points to the in-order successor or in-order predecessor. Any questions? Any questions from this part? Okay, so that's all for today. And the last part of the tree data structure is binary search tree. Okay, and there is a already recorded video, so which I recorded in the uh, last year. Okay, so that video is already available in the YouTube. So you can find that video. Or I can send you the link of that video on binary search tree. So that would be the last class. Okay, so on the video is already recorded, so I will send you the link of that video, so you can consider that video as the last class of this semester. So basically today we complete the syllabus, and another part, that is binary search tree, is already the video on binary search tree is already available. So I will send you the link of that video. Now, if you have any questions, you can ask me. Otherwise, we will stop now. No
Sir, all
question?
these recorded lectures and all this PPTs, please upload it in the Moodle platform.
Today I will upload
Okay, sir.
all those
Thank you,
videos.
sir.
Any other questions? And
No, sir.
tomorrow there will be lab. Okay. Tomorrow there will be lab from 1:30 to 3:30. So roll number 1 to 30. 1 to 30 will do their lab tomorrow. Okay. And rest of the roll numbers will do their lab on Thursday.
Okay, sir. Thank you,
Okay,
sir.
So
sir.
this week is the last week. Okay. This week is the last week of the lab classes. So try to attend the lab classes, and we will complete by this week, and in the next week we try to if there is any doubt clearing class, then we could have in the next week. Okay. When your end sem exam will start?
Sir, 26th.
Okay. Okay.
So proposed date is 26, but we have heard that there may be some change in the exam date, so we don't completely know.
No, the academic section is already communicated with you.
No, sir.
Okay. Okay. Accordingly, if there is any extension or there is any shifting of exam date, then we could have the viva before that. Okay.
Okay, sir.
So accordingly, we will change the viva date.
Okay, sir.
Okay.
And those who are having to submit their assignments, so they can submit by this week only. So in the next week, I will not accept any lab assignments. Okay. So this week Sunday is the last day to submit your assignments.
Okay, sir.
Okay. Okay, that's all for today.
Thank you, sir.